Exponential functions model a variety of different situations where quantities are growing or decaying exponentially. And one common example deals with finance. And this relates to all of us because most of us have some sort of a checking or savings account where we might be getting interest. So, our interest is generally compounded, and I'd like you to understand how compound interest works. So let's use this example, and we'll actually work through the math one time all the way through, and then hopefully develop the formula, and you can understand where the formula comes from. So how does it work? Let's say you have a credit union that's paying 6% interest per annum, compounded quarterly on some sort of savings plan, and we are depositing $100 and no additional funds, just the $100, and we're interested in how much would be in the account after 1 year. So, first of all, we want to make sure we understand what this means when we say that we're compounding quarterly. Our bank is compounding quarterly. That doesn't mean that we're getting the 6% 4 different times. It actually means that we're going to be getting our 6%, but it's going to be divided up into 4 equal chunks, essentially. So 6% divided by 4, that really means that our bank is going to be giving us 1.5% each time they compute our interest. So we start out with our $100, and then after the first quarter, the bank is going to give us the 1.5%. So we would be multiplying by 0.015, and that's going to give us the amount of money we're earning in interest. So that is $1.50. That's not how much money we have in the account, however. That's just how much interest we've gained. So we would have to add that $1.50 back to the $100 we started with to get our total amount, which would be $101.50. And that's how much we have in our account after the first quarter. So the beauty of compound interest is that now, after the second quarter, we don't have $100 in the account anymore. Now we have $101.50. So when the bank computes my interest and multiplies that by 0.015, I'm making just a little bit more money in interest. So I'm not making $1.50 this time. Now I'm making $1.52, approximately. And I'm rounding these answers to the hundredths place since we're talking about money. So $1.52 is what I've made in interest, but now I need to add that back to my $101.50. So after the second quarter, it looks like I have a total of $103.02. $103.02. All right. So third quarter, now I have $103.02. Let's see if we can start simplifying the process a bit. I'm going to multiply that by 0.015, and then I'm going to add it back to the $103.02 that I started with. And that's the math, really, that's going to give me my total amount of money after the third quarter. And this looks to be $104.56. Finally, one more time. Last quarter, we're looking at having $104.56. The bank will give us our 1.5% interest. We'll add it back to the $104.56 to get our grand total, which is after 1 year, which is $106.13. So this is how much money I'd have after 1 year if my interest is compounded quarterly. Now compare that with simple interest, meaning that if we just had our interest one time a year, then we would have had our $100. We would have earned our 6%, which is 0.06. So that means I would have earned $6 in interest, added back to my $100 initial investment. So simple interest would give me just $106 after the end of the year. So by compounding quarterly, I make a little bit more money. I make 13 more cents. So you can see this is a pretty tedious process, especially if our compoundings increase. A lot of banks compound monthly. So we would have to do this process 12 times just to see how much money you'd have after 1 year. daily 365 times. That could be pretty tedious. So let's see if we can kind of generalize and see what's happening. Just look at this work here for the last quarter. If we take a look at these two quantities that we really added to one another, you have a GCF. You could think of this as factoring out the 104.56, and notice what's left. 0.015 plus 1 if you factor. Now look at after the third quarter, similar work. Look at the two quantities. We have a GCF of the $103.02. So if you factored that out, you'd be left with 0.015 plus 1. And you could do the same for the first and the second quarters. So what I'm asking you to focus on is what I have here inside this parenthesis. Where did these numbers come from? Well, the 0.015, that was all the way back at the beginning. That was my interest rate, which was 6%, divided by 4, and 4 was the number of times my interest was compounded. So then the 1 essentially is representing the initial investment that I'm continuing to add to every time I'm computing my interest. You could think of this 1 essentially as 100%. So 100% written as a decimal would just be 1. And then the 0.015, that's the 1.5% that I'm gaining in interest each quarter. So now we can generalize this process and we'll get our compound interest formula, which then allows us to figure out how much money we have at any time without actually computing each individual quarter.